average is just average, like the speed, it's just the average speed that you're traveling over the period.
Yep, so over a long period of time, or in any period of time, you might say, this is my start, this is my finish, I've travelled this far in this time, distance divided by time. Yep. What's the difference between an instantaneous and an average then?
Instantaneous would be like the speed at a particular point in time.
Yep, very good. So your speed at a particular point in time. That'd be what you've got in your speedo, correct? That's your instantaneous rate. Your instantaneous rate of change is the speed of your speedo. Your average rate of change is like, look, I drove to Rocky in 3.5 hours, it's 350 kilometres away, I've travelled 100 kilometres an hour. Happy with that? Over that period of time, I would have travelled over 100, I would have travelled under 100. I would have travelled under the speed limit the whole time because I'm a law-abiding citizen. Clear? Speaking of law-abiding citizens, speed cameras, I wouldn't know how they work, but can anyone tell me how they do work?
Doesn't it like when you see the car, it starts in until it finishes the frame?
Yeah, so give me a run through how it works. How do you reckon a speed camera works?
Like they'd see it in one point and then keep tracking it all through the thing until they find the average of it.
So if I've got a car here, right, I've got my little vroom vroom car here. An odd looking vroom vroom car, it's travelling here. The camera takes a photo of it here.
It's like very speed.
Takes a photo, I don't know how to do a photo, but that'll do. A little photo here. Okay, it records the time, tick, tick, tick. I know it's the world's worst looking stopwatch. Tick, 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 and it takes another photo here. And if your little vroom vroom car gets between our two photos in a certain period of time, you get a little piece of mail from the government saying, well done, thank you for donating to our schools. Clear? Are we happy with that? So what is that? Is that an instantaneous or an average rate of change?
Average.
It's an average. But they use that to tell your instantaneous rate of change, correct? So how do they do that? How far apart are these cameras, or how far apart are the camera shots?
50 meters.
Very, like 10 metres, 50 metres might be, I don't exactly know, but it'll be about 10 metres or so, correct? So how can we make speed cameras more accurate? How can we make them, because they only care about your instantaneous speed. What happens when people see the speed camera and they're speeding? Hit the brakes, correct? So how could they make them more accurate? They want more money for schools.
Make the distance shorter.
Make the distance shorter, which means they need to make the time shorter, correct? Happy with that? Do we understand what I'm getting at here? They're using an average rate of change. How do they make it more accurate? Well, they reduce the time. They reduce the distance between the photos. Just keep that thought in our mind. We've recalled this function notation, fx equals whatever. What does this mean? Fx equals x squared plus 6, f2. What is that asking me to do then?
2 squared. 0.
Replace x with? Yep. So I'm saying, what's my y value at the point x? I sub that in and I solve, correct? I'm going to give us 30 seconds now. How can we find an instantaneous rate of change? I'll give you this function here, right? This is some function. If anyone can get this, I'll give them a chocolate. I want to know what the instantaneous rate of change is at the point 2. Tell me how I can do that. I want the instantaneous rate of change. Give me the best way I can do that. It is 10, but how do you do that?
Sub 2 into fx and then solve.
Oh, actually, it's not 10. It's not, sorry, I lied. X equals 10. I want the rate of change. So y equals 10 there, but I want the rate of change. I can tell you definitively the rate of change is 4. Tell me, you don't know how I did that, but tell me how you would do it. 30 seconds. Yeah, I'll give you a minute to think. Think about it. So I've done this on purpose, right? I've given you the speed camera example on purpose. So how can we find out an instantaneous rate of change at the point 2?
Could you rearrange to get x squared plus stuff?
Tip 1, we need to use an average rate of change. We need to use an average rate of change. So think about what we did with the warm-up. Do whatever with the warm-up. I need to use an average rate of change to find an instantaneous rate of change, or as close as I can get.
Add a third tip.
I will in a second. So my tips are, we need to use an average rate of change. How can we make speed cameras more accurate? Don't think big, think small.
I can't with something like that.
Yeah, give me, what have you come up with?
Well, would you go like F1, start would give you 7, but then 10 to take 7 doesn't make a difference.
So what you've done is you said F1 and F2.
So, yeah.
Not a bad thought, I like. You were very good start. You can be more accurate though. So you've got F1 is 7, F2 is 10. So you said 10 minus 7 over 1, which is 3 over 1. The actual answer is 4, so he's pretty close. His thinking's pretty good. He can be better, but I think you think it's too big. I think you're thinking way too big. Tom?
Can I do F0?
I think you're thinking bigger than he is. You're thinking bigger. You don't feel like you're thinking bigger, but Tom's thinking bigger than Harry.
Oh, so 2.
That's starting, but you need average rate of change, right? Could be a point. So what do I need for an average rate of change? I need how many points?
2.
2 points. You give me 1.
2 simultaneous equations.
Don't need simultaneous.
2 and 0 is 3 is radius, but you have a whole bunch of zeros, so there's no difference.
Yeah, so I want to reduce the difference, correct?
Yeah.
Good thinking.
Would you just do 2 equations?
I'll come over here and finish this off. So up here, right? Up here, I'm going to replace. I'll rewrite what I've written up there for our average rate of change before, but I'm going to do it a different way. Equals F5 minus F0 over 5 minus 0.
Would you make it F2 take?
So Abby's saying F2 take 0. I don't know if that's. I think you think it's too big.
I think too big. Would you just 2 on time? That's what you just said. Oh, 2 on top.
That's what I was thinking. But
Get decimal.
Mm.
Oh, divide by 100.
Harry was the closest so far. Harry's been the closest. He's had 2 and 1 of my points.
Harry's
And I said he's thinking too big.
1.5 and 2.
Closer.
1.9.
He's closer. Closer.
Oh, 1.95.
Closer.
1.9.
Ah, very good. So we got 1.9999999, or we can go 2 and 2.0, or we can go 1.99999 and 2.0001.
So
Correct?
basically
What happens, because this isn't, we're not bound by the constructions of our ability with a stopwatch. We can pick whatever numbers we want, correct? We can let x equal whatever we want. So for this example, let's let, I'm just going to get rid of this now, we don't need this, but that was a good average rate of change. So we're going to let f equal, what did you say, 1 point,
No.
let's just go 1.99. Sorry, I'll go that way. 1.2, sorry, 2.01 minus f of 1.99 divided by, what do I divide that by? 2.01 divided by minus?
1.99.
Okay, so can we shove that in our calculator, please? So we're going to need to find out what, I need to find out what f of 2.01 is. I need to find out what f of 1.99 is. I need to divide those by 0.02.
It's a 0.08 but
Just have a go. Have a go.
Sorry, but they don't mean.
Happy birthday.
Thank you for
For this function here, x squared plus 6. So what is 2.01 squared plus 6? I need a few decimals here. 10.0401. And I want 1.99 squared plus 6. 9.9601. Now can someone put that minus that to their calculator?
I can do it by head.
Okay, off you go.
Okay, everyone.
You're wrong.
Stop. 0.
No, you're wrong already.
0.
Has anyone got an answer?
0.04. Is when you take.
Oh, sorry, and then divide that by
I can't do it.
0.02. Got 4?
Four.
What did I say it wasn't the start?
Four.
Now there's a trick, I didn't do that in my head. There's a trick. There is a shortcut and you'll never ever do this again once you know the shortcut. Not never ever, but you won't come across it very often. But I'm going to show you the shortcut. How can I, well not the shortcut yet, I'm going to show you how this works. How can I make this more accurate? I'd argue that if I actually put out all the decimal places, I wouldn't get exactly 4. I've been very lucky there. I've just happened to get 4. How could I make this more accurate? What could I do? Could I use a better number than 2.01?
Yep.
2.001, correct?
Yeah.
And I could use 1.995, yep?